Hi friends, welcome to VTeach. So in today's class we are going to discuss about the mechanism of shear resistance. So in the last class we discussed how to calculate the shear stress. If you consider a rectangular block of shear, it is subjected to two principal stresses sigma 1 and sigma 2. There is a failure plane. So over that failure plane, wherever the tau is maximum, that is the maximum shear stress, and that maximum shear stress is equal to shear strength of the soil. So let's say this is the on this plane, you have to consider so many number of planes, trial planes, and I have considered so many planes like this. So many number of planes I have considered. Out of all, on this plane, tau value is the maximum. So this maximum shear stress is equal to shear strength of the soil. So in the last class we discussed about this topic. Now what is the basic shear resistance? Previously, what is the stress that is going to occur in a soil? Now how the soil is going to react? Okay, some shear stress is acting on the soil. How it is going to resist that shear stress? So that concept we are going to discuss in today's class. What is the shear resistance? So shear resistance, we already discussed that shear stress, whatever the tau value that is developing, that is equal to shear strength of the soil. Let's say yes, then only the soil will be in equilibrium. Okay, for example, the shear stress is more than the shear resistance. What will happen? The soil will fail. The soil already has certain shear strength value, but the coming shear stresses are more than the shear strength of the soil. So there might be a failure. So that is why in order to maintain the equilibrium condition, the shear stress will be equal to the shear strength. Okay, so the same point is given here, and that shear strength is produced from, or it may be derived from, three parameters, that is frictional resistance, interlocking of the particles, and cohesion and adhesion of the molecules. Okay, the shear strength equation according to Coulomb's law, it is given as C plus sigma tan pi. This is the Morse-Coulomb equation for the shear strength. Here S is the shear strength and C is the cohesion and sigma is the normal stress. So we discussed stress will have two components, one is normal to the plane, another one is parallel to the plane. So this is the normal stress, normal to the plane, and pi is nothing but angle of internal friction. Okay, so in this equation we have two parameters, one is pi, angle of internal friction, another one is C, cohesion. In case of cohesive soils, C value is maximum. In case of granular or coarse grain soils, pi value is maximum. So these two are the major parameters contributing the shear strength of the soil. Okay, the shear strength can be derived from these three parameters. One is frictional resistance, another one is interlocking of the particles, and the third one is cohesion and adhesion of the molecules. So let's see one by one. So the first one is granular soils. We have two parameters, right? C and pi. The granular soils, like the examples were sand, gravel. So these are the best examples for the granular soils. So these two soils, they are getting the shear strength from the pi value, from the friction and interlocking. So friction and interlocking are actually not two different terms. They are all directly related. The interlocking is possessing the friction. Okay, so the friction might be because of these two reasons, both sliding and rolling. We have two types of frictions. First one is sliding friction, second one is rolling friction. During these two conditions, the friction will develop. In case of granular soils, the frictional coefficient of angle of internal friction, pi value is the major parameter for calculating the shear strength. So what is the friction? So let's see how. These are the two parameters. So there has to be some contact surface. All the soil must have some contact surfaces, right? So whenever you apply the load, let's say this is the first particle and this is the second particle. So these two particles, one particle will try to move in a downward direction, but because of this contact area, friction will develop between the two surfaces. That friction is resisting this whatever the upcoming stresses are there. Okay, so it might be when the two particles are sliding about this contact area, or one particle is rolling over another particle. So during these two conditions, the friction will develop. Okay, so this friction is responsible for the shear strength in case of a coarse grain soils or granular soils. In granular soils, pi is the value that predominates the shear strength, and also C is equal to 0 for granular soils. Okay, What is our actual tau formula? Tau is equal to C plus sigma tan pi. But in case of granular soil, C is equal to 0. Then the equation will be C sigma tan pi. This is the equation for the shear strength of the soil for granular soils. Okay, so the pi is the one of the very important parameter that possesses the shear strength of the soil. So let's see the second one. Whereas in case of these fine grained soils, they will derive the shear strength from friction and cohesion. Okay, fine grained soils means like clay and silt. These are the fine grained soils. So these soil particles are very small in size, whereas if you observe these coarse grained soils, they are having somewhat relatively more size. The size of the particle is more, so obviously the contact area will also be more. The friction is depending upon the contact area. If the contact area is more friction will develop. If the contact area is less friction will develop. Okay. Here these are fine grained soils. The size of the particles is very less. Okay. So the contact area between them is also very less. So for that very small contact area, the friction will not develop. It will develop, but it will be very less only. So in case of these fine grained soils, cohesion is the major parameter. What is cohesion? For example, this is the soil sample. This is also soil sample. So these two soil samples will always attract each other. So that attraction force between two similar soil particles is known as cohesion. Okay, whereas let's say I am considering a foundation. I have laid a foundation on the soil. So this is a foundation, that means PCC, and this is a soil. This is soil and this is PCC, plain cement concrete, foundation material. These two material also will always attract each other. So the attractive force between two different particles, that is known as the adhesion. Okay, so this cohesion force is the major force in case of a fine grained soils, and pi is also will develop, but the contact area is very less. So for that very small contact area, the pi development will also be less. Here C is the predominant factor and here pi is the predominant factor. Okay, so these two are the major factors for that is possessing the shear strength of the soil. The friction and interlocking, even though they are we have written as a two parameters, but they two are as a single parameter. The interlocking itself is possessing the friction. We cannot measure what is the interlocking of the particles and its relation for the shear strength. The interlocking is possessing the friction, and the friction is related to the shear strength of the soil. Okay, and for example, if it is a highly plastic clay, for highly plastic clay or pure clays, they have only the cohesion, that is their only source of shear strength. For in case of coarse grained soils, what we discussed, C is equal to 0, right? C is equal to 0 for coarse granular soils. Similarly, here in case of this high plastic clays or pure clays, pi is equal to 0 for pure clays. What is our equation? Tau is equal to C plus sigma tan pi. So for pure clays, pi is equal to 0. So pi is equal to 0 means tan 0. Tan 0 is 0. 0 into sigma 0. So tau is equal to C only. This is for pure clays or high plastic clays. Okay, this is the equation. So for high plastic clays or pure clays, however, only cohesion as their source of shear strength. Cohesion is the only source of their shear strength. For the granular soils, pi is the only source of shear strength. Okay, so these are the three major parameters that will possess the shear strength for the soil. So with this I am stopping today's lecture. We will continue the session in our next class. Thank you.